I'm just wondering, okay, because we know that the dot product is related to the angle. We looked at that last lesson. Yeah, so we literally said the dot product is used to find the angle between two vectors. Can we infer anything from the dot product at all about the angle between the two vectors?
Dot product between?
So here we've got this formula here, okay? So because I know the dot product of these two vectors is positive 32, can I infer anything about the angle between those two vectors? Have a think about this. I know that cos theta, so if I rearrange this, I've just proved it to you, I know that cosine of theta should be equal to, so if I times this by u dot v.
It will be positive value, like it will be between 0 to 1.
Ah!
0 to minus 1.
Interesting. So you're thinking about cosine of theta, okay? Now let's think, okay? I know in this case that u dot v is positive, okay? So we've got three options. It can either be positive, it can be 0, or it could be negative, okay? Now are you happy that because I'm dividing by the magnitude of u and v, the magnitude of u and v is always going to be positive, right? So whatever this is, positive, negative, or 0, and because it's always going to be positive, I'm taking that, dividing it by a positive, it means that the sign remains the same after I divide it by u times v, the magnitude of u times v. Yes. Is that okay? So therefore, I'm basically saying that the cosine of theta is related to whatever the sine is of u dot v. You happy with that? Because that is not going to affect the sign at all. This denominator is not going to affect the sign. Is that okay with everyone? Okay. So let's think about the cosine graph, right? Now I said right at the very start, if you find the angle between the two vectors, that angle is generally either acute or obtuse. In other words, it's got to be less than 180 degrees, because you would never look at that angle round there. Okay, you always look at the obtuse or the acute angle. So it's got to be less than 180. So if I think about the cosine graph between 0 and 180 degrees, would you be happy that that would be that? Yeah, that's a cosine graph. So this is 0, this is 1, this is negative 1. Let's do it in degrees. What's that point there? In degrees?
In 90.
And what's that point there? 180. So because I know that this thing, the cosine of theta, the cosine of the angle between the two vectors, can be approximated by the dot product of u and v. Have you got a question?
No.
Okay. The dot product of u... Why have you got your hand in there then?
I'm just searching.
Okay. Well, so the dot product of u and v can approximate cosine theta, the sine of it. Okay. Let's have a look at the sine of the cosine graph. Would you be happy that between 0 and 90 degrees, in other words, for angles between the two vectors that are acute, would you be happy that the cosine of that angle must always be positive? You happy with that? Yeah, because it's always positive between 0 and 90 degrees. Okay. So if u dot v, because u dot v is approximated by the cosine of theta, if u dot v is positive, okay, so in other words greater than 0, then I know that the angle between the two vectors must be acute. Does that make sense to everyone? Okay. Now also, if I know that if I deal with an obtuse angle, in other words, an angle between 90 and 180 degrees, okay, cosine of theta is negative for that angle. Yeah? So therefore, if u dot v, because u dot v is approximated by cosine of theta, if u dot v is less than 0, in other words, negative, then that must mean that theta is obtuse. Okay? In other words, they're pointing in roughly opposite directions. Okay? So if it's acute, it means they're pointing in roughly the same direction. If it's obtuse, it must mean they're pointing in roughly opposite directions. The last situation is for theta equals 90 degrees. Okay? In other words, if the angle between the two vectors is 90 degrees, it means that they are perpendicular. Make sense? Yeah? So therefore, if u dot v, so for 90 degrees, the cosine of 90 is 0. If u dot v is equal to 0, it means that theta is 90 degrees. So therefore, u and v are perpendicular to each other. Okay? So in other words, the three situations you've got, if u dot v comes out as positive, like we have down here, I must know that the angle between the two vectors is acute. In other words, they're pointing in roughly the same direction. Okay? If u dot v is equal to 0, so if I did this thing, u dot v, it comes out as 0, it means that u and v are perpendicular to each other. They're right angles to each other. Okay, so u and v. Okay, so that's 90 degrees for theta. The last situation is if u dot v is negative. If it's negative, it must be obtuse. So it means that u and v are pointing in roughly opposite directions. Does that make sense? So actually, just by using u dot v, that's usually enough to tell you how the two vectors are orientated. Does that make sense to everyone?
Yeah.
Good. So you notice that for 6 part 3, I found the dot product of u dot v. I'm expecting the angle between the two vectors. Because that is positive, I'm expecting the angle between the two vectors to be good. So it is acute. You're dead right, between 0 and 90 degrees. Okay. So always use this little check. Okay, because it's when you're doing the question, you're always, if it asks to find the angle between two vectors, you're always going to have to end up doing the dot product anyway. So always check. If it's positive, it means it's acute. If it's equal to 0, it means it's perpendicular. And if it's less than 0, it means it's obtuse. Okay?